Good afternoon everybody, it's Charlie ZL2CTM. Well, I'm back off that business trip and had an opportunity this afternoon just to do a bit of coding on the Teensy to play around with some transmit tests. We'll look at the code in a second. What I've done, I've just basically stripped out all the receive side of the house and just put in some test transmit code that we can then later on turn around and turn that into a full transceiver. So we covered, before I went away, some hardware configuration changes which are now in here. We've got the output of the Teensy, the I and the Q, going through those two isolation transformers into the two NE612s, where they're being mixed up to our desired transmit frequency, then being recombined here, and then out goes, it's through the bandpass filter to the antenna. That's what we're basically seeing here. So the two grey wires are coming out of the line out of the Teensy, going through those two isolation transformers, the red ones here, into the NE612, and then coming out through those two yellow lines there to our transformer, and then through the bandpass filter and out. The yellow wire here is loosely coupled to the receiver up here, which we'll look at in a sec. In software, what I've done, and like I say, we'll look at the software in a sec, we have the microphone that's coming in through the line in. Now the line in is configured to be the microphone input, and we saw that the other day. That's the yellow wire coming in here into the audio panel. That's going straight into two Hilbert transforms, one plus 45 degrees and one minus 45 degrees. And the band pass for those is 2700 Hertz or 2700. Now the I channel is then going through, and we'll see in the software called a, I've notionally called it a sideband select switch, and if the frequency needs to be, or the transmission needs to be more the point lower sideband, it does not get inverted. It actually just gets multiplied by 1, so it goes straight through. And then if we need upper sideband, it gets multiplied by -1, so that output is just totally inverted, and out it goes. The quadrature channel, which I've just notionally taken from the minus 45 degrees Hilbert transform, goes straight out. And like I say, in software we'll look at that. So to the hardware itself, let's see if I can just sort of zoom out there a bit. We've got a receiving radio up here. The antenna is just loosely coupled in the back, and we are using that radio there just to monitor the output of this. As you can imagine, it's very low power at the moment. There's no amplification at all, so the output of those two NE612s, once they're combined in that transformer there, the output of the two bandpass filters, one for 20 meters and one for 80 meters, is just going straight out. This switch here is on, I'm just using it backwards, it's on bypass mode, so this receive amplifier is not being used at all. So whatever's going in is going straight through the switch and out the other side. At the moment, just for test purposes, I have not configured the PTT, so it's just hot transmit. As you can see down here, our transmit frequency is 3690, and our receive frequency up on the radio is 3690. So if we were just to bring up the amplifier, the microphone gain, and we can talk into this, hello ZL2 Charlie Tango Mike, I'll just crank that volume up a bit. ZL2 Charlie Tango Mike testing 1 2 3 4 5. So that's coming through lower sideband. And if we just zoom up on that, so testing 1 2 3, that's the volume down, 1 2 3 4 5, ZL2 Charlie Tango Mike, and that's now upper sideband, so nothing coming through an upper sideband, 1 2 3 4 5, 1 2 3 4 5, ZL2 Charlie Tango Mike, 1 2 3 4 5, 1 2 3 4 5, ZL2 ZL2 1 2 3 4 5. I've got a bit of hiss coming through there. Like I say, it's just loosely coupled. So what I'm going to do now, I'm going to reprogram the Teensy on the fly, and I'm going to set it up to the 20 meter band, and what that will do in the code is test this inverter here, and then we'll just see how that works out. So let me just change this line of code here and push that back up, and we should see this reprogram itself any second with the new transmit frequency of 14190. So what we can do now is we can go back up to here, up to 20 meter, 14190, and on lower sideband we wouldn't expect anything. 123, 123, and oops, daisy, just got to change over the bandpass filter. 1 2 3 4 5 ZL2 Charlie Tango Mike, and up here I think this radio is out by a slight amount, so I might actually just double check if it's this radio here which is at fault, or the transmitter. I suspect it's this one here. Oops, a bit of feedback there. So ZL2 Charlie Tango Mike now receiving on 20 meters, so it's upper sideband, and then nothing coming through in the lower sideband now. Nothing at all, and then coming back through there on the upper sideband. So like I say, all that's done there in software is basically just, excuse me for the poor graphics here, it's just inverted it now, and that's basically now recombined, and through the maths we have created a upper sideband transmission, and that is extremely simple to do in the software, which we'll see in a sec. So what I'll do later on when we turn the software into fully fledged transceiver is on the fly, when the frequency is being changed, we'll just check to see, well, we can do one of two things. We can either have the software monitoring the frequency and then making a determination if that particular band should be upper sideband or lower sideband, or probably the more conventional method would be just to have an upper sideband and a lower sideband switch, which we'll probably do. We've got that new band that's coming now, which traditionally is down in the lower sideband region, but is actually transmitting on upper sideband. So I think we'll just have an upper sideband, lower sideband switch, which is easy enough to do there. Just have it being monitored by the teensy, and then just turning on or off that inverter. So like I say, that's just a quick demo there of the teensy using the line out through back to those NE612s being combined and outputted as a means of generating single sideband transmissions. So what we'll do now is we'll just break here and we'll have a look at the software. Okay, so let's take a look at the code. What I've done with the code here is I've stripped out all of the receive lines that we had in the previous video, and just included transmit code. I've done that to try and make it a little bit sort of clearer, I guess, in trying to explain how the transmitter works. And then in the next video, we'll look to combine both the receive functions and the transmit functions and turn it into a transceiver. So like I say, at the moment, all the lines of code in here are just for the transmit, and there's actually very few changes. Right, so couple of things a couple of constants we've defined early up, and you'll see how those are used further down. We have mic gain and line out gain. Now the mic gain, if you go to the teensy audio design tool, that web page I showed you a couple of videos back, you will see how to use the mic gain for the audio shield. It's a number that ranges from 0 to 63, and it's in dB. So at the moment I've got it set for 0 dB, so I'm not providing any additional amplification to the mic gain coming in, or the mic channel. The line out, we'll be using the line out of that audio shield, and if you recall that diagram, those are the two lines that go via the isolation transformers to the two NE612s. You can also have the gain of those two channels adjusted. The range is from 13 to 31, where 13 is 3.16 volts peak to peak, and 31 is 1.16 volts peak to peak. There is a table of the intermediate values. If you go again to that audio design tool page, you'll see there the whole table with the various values, and I'm just notionally using at this stage a value of 20. Just sort of moving down, absolutely no changes to those two Hilbert transform coefficients. So what we'll be using for the transmitter is what we were using for the receiver. So down in terms of defining objects, here we've got, though, again using a fur filter. That's part of the audio library of the Teensy, and we're going to call one of those filters, we're going to call transmit Hilbert plus 45, which is very similar to what we had for the receiver, which was receive Hilbert plus 45, and we have another one for the transmit side for the minus 45, so there's the TX there. And we're also using this mixer to invert or not invert the the in phase line. So if you recall back to that pencil drawing I showed you just before, that top line goes through this mixer here, and that's just a nice, easy and convenient way of inverting it if it's required for the upper sideband, and we'll look at that further down. The audio connections, again using those patch cords. So now if you recall that diagram I had, the microphone is coming in, and that's what we see here with audio input. When you see audio input here, just think microphone. So the microphone 0 channel, there is only, it's a mono microphone, so it only has the 0 channel. We're feeding one into the transmit plus 45, and we're feeding that same microphone audio to the transmit minus 45. So that's exactly as per that line drawing we had before. Now, thinking about that top line, the output of the plus is now going into that sideband switch, which we'll be using to either invert it or not invert it. And conversely, the output, and the output of that, which is there, goes to the audio output. And when you see audio output in this context, it is line out, which we'll see later on, to the left channel. And then the other line, which is from the minus 45, that just goes straight from the Hilbert transform straight to line out on the right channel, which is number 1. And that's per that line drawing. It doesn't go via any kind of switching or inverting, it just goes straight out. So that's now just essentially codified, wrong term, but we'll use it, that line drawing. So in terms of the setup, the only change I've made here is in regards to calling a function called turn on transmitter. On the receiver version, the previous video, that was turn on receiver. So I've just stripped that away and using a function called turn on transmitter. No changes to the main loop, and here goes that function after the loop, of course, which is turn on transmitter. So for a start, turning off the interrupts, and this is where we set things up. So audio shield input select, we're now saying it's the audio input mic. You recall on the receiver that was the audio line in, but no, we're using the microphone. So that's how we define it. We talked about the microphone gain, that's how we assign it there. So audio shield.mic gain, a number, and the default number that we're using for this one, as we saw further up, is 0. We want to unmute the line out because we're going to use that to feed the signals to the two audio isolation transformers before going to the 612s. So we need to unmute that. and we can also assign or adjust the level of the line out. So in this particular case, we can use that number that we had assigned further up, which was 20. So if you want to play around with that, depending on what what additional hardware or changes in hardware, then all we need to do at the top of the program is just change these two values here to suit the type of microphone and the downstream hardware. So it's a nice easy way of adjusting those. And we also need to, in turning on the transmitter, is to start or begin, is the formal name, those two fur filters. So one is the transmit plus, one is the minus 45. So here we go again. The dot begins, tell it whereabouts the coefficients are and how many there are. So this right hand side here is exactly the same format as we saw for the receive fur filters. In this particular case, we're just calling them two different things. So that's nice and easy. And then the bit where we invert the I channel is done here. So at the moment, I'm saying anything less than 10 megs is lower sideband, and for lower sideband we do nothing to that I channel. So what comes out of that fur filter is going to go in through the first input, which is 0. It's going to be multiplied by 1. So 1 times, or any number times 1 is the same number, so no change. So it's going to go straight out via the line out, so no change at all. However, if it's above 10 megs, we want it to be upper sideband. And in order to do that, for this radio's configuration, we need to invert it. So because it's going into the first input, which is called 0, and we're now just multiplying that by -1. In other words, it's being inverted. And then just re-enabling the interrupts again. So that section of code there enables our transmitter. No other changes to the software at all, so in terms of changing the frequency, etc. This section of code here will change when we turn this into a transceiver, because rather than it actually just testing the frequency and doing something, we will test the state of the upper sideband, lower sideband switch and then do it. So that is going to be monitored within the loop here. So within the loop, it will always monitor to see if the upper sideband or lower sideband switch has been switched, and then we will act upon that. We will also, within this loop here, test to see if the PTT switch has been made, and if the radio has been keyed, then we will turn on the transmitter and turn off the receiver, and then when the PTT switch is released, we will then call a function to turn off the transmitter and turn on the receiver, and that's pretty straightforward. So we'll build that code in the next version of the software. In other words, we'll combine the receive code with the transmit code, do a bit of massaging, and turn it into a full transceiver. Anyway, so I'll break there. So hopefully that provided a little bit of clarity into setting up the transmit side of the house, so the software, in order to generate those two signals, the I and the Q, that will then feed into the two NE612s and on. And as you can see, it is very few lines of code indeed required to do that. It doesn't take much at all, which is all credit to Paul and the rest that created that library for the teensy. Anyway, I'll leave it there. And just for interest's sake, earlier in the video when I said I pushed up a new frequency for testing, that was those two lines of code here. So all I was doing was just either commenting one or the other. So initially it was that one, and then I changed to 14190 and just recompiled it and re-pushed it up, just to force the code to see, oh yes, it's above 10 megs, so therefore I need to invert that I channel. Of course, with the transceiver, the next version, that will disappear. This is just purely test code just to show it working. Right, I'll leave it there. I'll combine these two sections, push it up, and like I say, the next video will be looking at the transceiver and what's needed to do there. So wire up a few more switches. We'll wire up that PTT. And then we'll write the code to detect what's going on and to make the various configuration changes. Anyway, I'll say 73s, and we'll continue playing around. Okay, cheers all.